those undo each other, the answer is sitting right in front of my face. But without doing this, maybe you wouldn't see it. So I could write another one real fast. I could say log base 7. I'm going to raise 7 to the log base 7 of 3. Do that better here. 7 raised to log base 7 of 3. What's this equal? 3. Absolutely. So maybe now on the rest of the worksheet here, you can tell me quickly. 35, what's the answer? Number 34, what's the answer? And number 36, what's the answer? What is it? Okay, what happened? 36 didn't work because the base and the exponent are not the same, or the base and the base of the log are not the same. Okay, so let's take a look at 36 and see how we might deal with that.
Just change the 9 to 3 cubed.
Say that again?
Can you change the 9 to 3 squared, I mean?
Yes, exactly what you do. 9 raised to log base 3 of 20 is the same thing as 3 squared, which is 9, raised to log base 3 of 20. And when you raise a power to a power, what do? Multiply 3 times 2 log base 3 of 20. Now, this is something you probably don't know, and I'm going to have to figure out how to motivate this. Well, watch this. I'm going to do it, and then I'm going to explain it, okay? Because I don't really know how to motivate this. This is the same thing as 3 log base 3 of 20 times 3 log base 3 of 20. Now, you see these two bases are the same? When you have the same bases and you're multiplying, what do you do with the exponents? So this is log base 3 of 20 plus log base 3 of 20, also known as 2 of them. That's a stretch, but you got it? Now what's this value? Times, what's this value? 20. Check the answers. Make sure I got it. Now there's actually another way to do this.
Yep.
Is that right? There's another way to do this, which you haven't learned yet, but I'll show it to you now, just so when you do see it, you will be so for the first time. That's familiar. When you have a number in front of a logarithmic function, you have the ability to move that number. And here's where you can move it. You can move it right up on top of that thing and write log base 3 of 20 squared. Now if I had done that, I'd have 3 log base 3 of 20 squared. These two things are now the same base. What's the answer here? 20 squared, which is also 400. That is a neat trick. One of the reasons we use logs is we can actually knock exponents down using logarithms. You don't know this yet. This is about 2 chapter sections ahead of where we are. So you couldn't have used this neat little rule here, supposedly, because you don't know it. So what I did instead was stick to what I do know. You do know that when you add the two bases together, that you add the exponent. So if that's 2 of them, then it must have come from one on each. And from each one of these, we just learned that they're inverse functions. So that's how I did it. Okay, so who am I thoroughly confused?
I got a question about it. I went ahead, when I did it, instead of taking the 9 down and putting it through, making it smaller to equal the both being the same.
Okay.
I squared. I knew I had to square the 3 so they equal 9. Therefore, I had to square the 20 in the log, and it still came out as 400. Is that something that would still be able to do later on? Is
That's a good technique. It
So
works
no,
because
if you use
what you
one
did is
side,
this, you
both
said,
sides.
we're just going to look at this part for a second and try to turn it into something 9. So what you said was, log base 3 of 20 is what we're looking at. Well, this is equal to some x, which means that 3 to the x is equal to 20. Lord knows what x is there, but 3 to the x equals 20. Well, if you square this, that becomes a square in here, then that's going to make this a square also, because you're basically squaring both sides of the equation. So it is legal to do this. So by making this a 9, you made that a 400. It is legal to do that. But we're going to figure out, I don't know how to say this, more efficient ways than that, I suppose. But it is good that you saw that, because it is true that when you create an exponential equation, we're raising both sides to the second power. That means in these things, you can raise these things at will to whatever power you want. Well, not whatever power you want to. There's one that you wouldn't want to do, which is the one you wouldn't want to do. Yeah, don't raise it to the 0 power, because that doesn't do wonderful things. But other than that, you can do. So when I say whatever you want to, I mean within bounds, right? Within some bounds. The base can't be what? Well, you can't raise a positive power to get negative anyways. The only thing you can do is raise it to 0 to get 1. And the base is not allowed to be 1, remember? So we got to just say you can raise it to anything you want to except 0. But that's the same thing. 0 always gets in the way of everything. You can't divide by 0. You shouldn't multiply two sides of an equation by 0 either, right? You're trying to solve an equation, you multiply both sides by 0, well, might as well get your eraser out. Did the same thing, right? So, there's limitations as to what you can do, but yes. All right. Let's go ahead and take a look at some of the ones in the book so we can have some examples. While I have your attention over here at the homework, though, I want to point out something in case I haven't. There is no class on Tuesday. 11, is that 6? 6. No, 8. 8 or 9. What is it?
What is the 10th class?
No,
It's 10.
10, yeah.
Tuesday's the 10th? Yep.
Tuesday's the 9th.
Tuesday's the 10th.
Wednesday's the 10th. I'm just saying, you told us the 10th.
No, Wednesday's the 11th. I know Wednesday's
Yep.
the 11th, so Tuesday must be the 10th. Okay. I'm just reminding you guys, there's no class on Tuesday, whatever date it is. I think it's definitely the 10th, because Wednesday is November 11th, which is Veterans Day, which there's no school that day either. College is closed on Wednesday. So, not that you guys have to worry about my class that day, but that means you'll have a break from my class and from all your other classes on Wednesday next week. So this homework is coming along. It's 1 through 95 odd. So let's take a look at some of those and see what we can do.
When's the next test?
I think it's scheduled for the 19th or 18th or something like that. But we may have to push it a couple days. But we'll see. We'll see when we get back on track. On Thursday of next week, we'll know a little bit more where we are. I think I can still meet the date, but I'm not sure. Okay, 464. Okay, for the first section in 464, now it's your turn to change all those exponential equations into logarithmic form. We just spent a great deal of time doing that. I'll do one, and you guys can do the rest. So this is now at number 8. Nice easy one. We have 10 to the 4th power equal to 10,000. How do I change that back to a log? Well, I'll write the word log. What's the base?
10.
Okay, what goes next? 10,000 equals to? Okay, and log base 10 is one that you have on your calculator. So if you don't mind right now, if you can push on your calculator the word log, notice it does not show a 10. You hardly ever write log with the 10 down there, kind of like when you write the square root and you put a 2 in here. So the log without a base is assumed to be log 10. So if you hit log and then type in 10,000 and hit enter on your calculator,